Hello everyone, I'm Wael Aldhaheri. In this video I'll talk about parallel imaging in MRI. First we'll talk briefly about the theory of MRI and then case space, and finally we'll discuss parallel imaging. An MRI image is basically a hydrogen distribution map, although it can be for different atoms that have an odd number of protons, but most commonly it's used for hydrogen atoms. To get that image, first of all a magnetic field is applied, causing the atoms to align, or most of the atoms to align with the magnetic field, and then the atoms act as a radio attuned to a certain frequency called the Larmor frequency, which is dependent on the magnetic field strength and a constant that is unique for each atom. After that, an RF pulse is sent at that Larmor frequency, causing the atoms to store energy. After the RF pulse is turned off, the energy is received back and measured, which gives us the number of hydrogen atoms in the whole body. If we stopped here, we would just get the number of hydrogen atoms in the whole body, which is not really useful in terms of imaging. So we use spatial encoding to discern signals from different positions in the body. Before we talk about K-space is the same. K-space and the image domain is the same as has the same relationship as time domain and frequency domain. Signals in time domain can be transferred to the frequency domain using Fourier transform. In the same way, K-space data we can construct the image from the K-space data using Fourier transform. The K-space can be filled using different sequences. There are two main factors which determine the sequence. There's the phase encoding and then the frequency encoding. Frequency encoding is in the x-axis and the phase encoding is in the y-axis. In parallel imaging, we reduce the number of phase encoding steps by a factor of r. The positive side is that it reduces the acquisition time by r, but the problem is that it also reduces the signal to noise ratio by a factor of square root of r. In parallel imaging, multiple coils are used. In this example, we'll discuss how two coils are used. In normal non-parallel MRI, if there are multiple coils, the output of these coils are combined first before the image is processed. But in parallel imaging, because each coil is differently sensitive to different regions. So, for example, this red coil is more sensitive to this red region, and this blue coil is more sensitive to this blue region because it's closer to it. The output of each coil is processed separately in parallel, so they're both processed simultaneously. And then using the sensitivity information, the spatial localization can be determined using different algorithms like SENSE or SMASH or GRAPPA. These different algorithms uses the data from the different coils and the sensitivity information to get the final image output. Thank you for watching, and if you have any questions, please leave them in the comments below.